Okay, a simple one here, but one that most people get mixed up with, even now. And that's the difference between mass and weight. And you can go back to the way you're thinking after you've finished your physics exam, but it's very important that you know the difference before you do it so that you can write the right answer. Now, you've got two words here, mass and weight. And unfortunately, all we ever talk about is how much do you weigh? We ask people, how much do you weigh? Get on the scales, how much do you weigh? God, my goodness. Right, well, we're not really doing it right because what we're really measuring is our mass, how much space we take up. Let's look at this Lego man. He's made out of bits of Lego. And if I got all the bits of Lego here in a pile and I put it on some scales, I could work out the mass in kilograms. So a mass of something is how much space you take up. It's measured in kilograms, okay? Kilograms. All right? Marvelous. So kilograms is mass. It's if you took all your bits apart, like put it on some scales, is how much mass would there be in kilograms. Now, unfortunately, we tend to say, oh, how much do you weigh? And then in America especially, they say it in kilograms, but we're wrong. What we should say, if somebody asks you how much you weigh, you have to say how much you weigh in newtons, because weight is a force, and it's a force that you put on the floor, or in it acts with gravity, really. If you imagine you're jumping out of a plane, your weight and gravity is causing you to fall. So it's a force weight. So this person here can be measuring their weight. The only way they can be measuring their weight is if this little readout here says newtons, because it's a force, and we all know that we measure forces in newtons. So your mass is in kilograms, okay? All the little bits, how much space you take up, stick it on some scales, some kilograms. And your weight is how much force you are putting on the floor. And you can measure it with some scales, but only if they're Newton scales. Now, can these change your weight and mass? Well, of course, you can go on a diet, but it's not about that. Let's have a look. Here are people's mass, okay? The space they take up on Earth is the same as the space that they take up on the moon. Imagine you're a Lego person and you put all the bits of Lego, yeah, blah, 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 put it on some scales, it's 60 kilograms, whether you were standing on the Earth or the moon. So you would have a mass of 60 kilograms. The space you take up in all these little bits here, 60 kilograms. However, if you were to measure your weight, okay, so your weight, it would change. Now here, well, how you work it out is you've got to look at gravity, and this here is the gravitational field strength of Earth. Okay, so Earth, the planet Earth, pulls down on every kilogram you have by 10 newtons. It's very simple to work out then, because if you can see here, your mass times the gravitational field strength will give you your weight, 600 newtons. So if you were 70 kilograms times 10, you'd be 700 newtons on Earth. However, your weight can change if you go to different planets. Not likely. You could go to the moon. Not likely, but you might do. You never know. Now on the moon, you've seen astronauts bouncing about on the moon, or maybe you haven't. Have a look on YouTube if you wish. Now on the moon, you have the same mass, 60 kilograms, as space you take up. But here, gravity is much less. So the force you put on the floor, it's not pulling you down as much. So the force that you're putting on the floor is going to be less. And to work it out, it's 60 times 1.6, because that's the gravitational field strength on the moon. And 60 times 1.6 will give you a weight of 96 newtons. Fabulous. You've lost weight just by going to the moon. A little bit drastic, but that's it. So units, kilograms for mass, newtons for weight, and this is gravity, newtons per kilogram, how much it's pulling you down. Fabulous. Sorted.